right, hi algebra kids. I can't remember if we did this or not. So we are going to have a review of it so that if we did do it, it'll just be an easy assignment for you to do, and I'll make a quizzes for you for tomorrow. Tomorrow meaning Tuesday, March 24th. So let's just review this, and if not, then this is pretty, if I didn't already talk about this, is actually pretty easy. We're going to look at simplifying radicals that are not perfect squares and where you can't use your calculator. So like for square root of 64, the number underneath this sign, what we've used to call the square root sign, is actually called the radical sign. And the number underneath it is called the radicand. Now you're used to like the square root of 64 is 8. We would call 8 the square root. And those are perfect squares. Like the square root of 36 is 6. That's perfect. The square root of 16 is 4. That's perfect. The square root of 81 is 9. That's perfect as well. But what happens if you don't have a perfect square and you're not allowed to use your calculator, or what they will say in algebra is they want the exact answer. The problem is when you take the square root of a number that's not a perfect square, it gives you an irrational number, and that number is not exact. So in order to get it in order to get it exact, we're going to simplify it and pull out any perfect squares. So the first thing you're going to do, I don't know if y'all remember doing factor trees back in elementary school. You'd have 14, let's start with something else. It's like you have 28 and you would do 7 and 4. These were prime factorization trees. And then you'd break down 4 to 2 and 2. And then when you wrote this out, you would have 2 times 2 times 7, or you can write it as 2 squared times 7. Those were prime factorization trees. Well, what we're going to do is we're going to do the same thing here. We're going to break these down to prime numbers if you want, or any prime and perfect. For example, 18, you come up with 2 factors, would be 9 and 2. Now 2, I'm going to circle because it's prime. And 9, I can either break it down to 3 times 3 and then circle those, or I could simply stop and circle 9. Then what I'm going to do is I'm going to rewrite this. I'm going to have 2 times 3 times 3. And then I'm going to look underneath the radical sign, and do I have any duplicates, any pairs of numbers? We do, 3, because 3 times 3 is 9. So I'm going to pull out 3 times 3 is 9, square root of 9 is 3. So this would be 3 times the square root of 2. Now if I had not done this part and just circled the 9, I'd have on the inside of the radical, I'd have 2 times 9. Well, that's a perfect square. The square root of 9 is 3. And I end up with 3 times the square root of 2. Okay. Let's look at 24. All right, what are 2 factors of 24? You can start with any 2 factors you want. I'm always going to try to start with ones that are perfect squares, because I'm going to stop here at the perfect squares instead of factoring them all the way down to prime factorization. So 24, I'm going to do 6 times 4. And I'm going to circle 4 because 4 is a perfect square. And then I'm going to break down 6 to 2 times 3. And I'm going to circle all my prime numbers and my perfect squares. Then I'm going to rewrite it, make my long radical sign, and I'm going to put them in numerical order. I have a 2, a 3, and a 4. Well, 2 and 3 are prime. I'm going to leave it, but I do have a perfect square, which is 4. Square root of 4 is 2. So I have a 2 on the outside, and I'm left with 2 times 3 on the inside, and you multiply that together. 2 times 3 is going to be 6. So my final answer would be 2 times the radical of 6. Okay. All right, let's look at a couple more. What if I have the square root of 300? Think of any numbers that are perfect squares. So it should be going off in your head 100. So this is going to be 100 times 3. 100 I'm going to circle because it's perfect. 3 I'm going to circle because it's prime. So when I come down here, I'm going to do 3 times 100. Now the square root of 100 is 10. So my answer is going to be 10 times the square root of 3. Again, that's the exact answer. 48. I am going to do, so maybe we can start. I'm going to do 4 and 12 because 4 is perfect. And I'm going to circle 4. And then 12, I'm going to do 4 and 3 because 4 is perfect and 3 is prime. And then I'm done. So then I'm going to have lifted in order 3 times 4 times 4. Now, I either have a pair of 4s that I can circle and say 4 times 4 is 16, square root of 16 is 4, or simply pull out each root. Square root of 4 is 2, square root of 4 is 2. Now, however many numbers you pull out here on the outside, you just multiply them together. So 2 times 2 is going to be 4, and left underneath the radical sign is 3. All right, let's see if we can do another one in here. Now, what if we had, black marker, sorry. What if I had 2 times the radical of 96? It's not gonna, you're not going to hear it say square root anymore because that's not a perfect square. So we're going to start off, let's start off with 2 factors that can go into 96. I'm just going to start with 3. 3 goes into 9 3 times. 3 goes into 6 twice. I'm going to circle that. Ooh, and I'm going to do 8 times 4. I'm going to circle 4 because it's perfect. And then I'm going to do 4 times 2, prime, perfect. So then what I'm going to do is I'm going to write this really big long radical sign. And I need to put all these numbers that I have circled underneath the radical sign in order. I have a 2, a 3, a 4, and a 4. So 2, a 3, and a 4, and a 4. Now, what about this guy? Where do you think he goes? The 2. Just put him out front. So all that means is when I pull stuff out, I'm going to end up multiplying it by 2. Again, I would circle this and say in my head, well, 4 times 4 is 16. Square root of 16 is 4. So then the numbers on the outside I multiply together. 2 times 4 is 8. The numbers on the inside I multiply together. 2 times 3 is 6. So your answer for 2 times the radical of 96 would actually be 8 times the radical of 6. That's the exact answer. Okay? All right. Now what if I have letters? Ooh, not that bad. A to the 4, how many A's is that? A, 4. So this is actually what we're going to do is we're going to write it in expanded form. So we're going to say A times A times A times A. Now, each A is a pair because A times A is A squared. The square root of A is going to be A. A times A is A squared. The square root of A is going to be A. Now, I have nothing left underneath the radical sign. So what happens to the radical sign? It's gone. So I'm left with A times A on the outside, which would simply just be A squared. All right, let's look on the second one. Let's do an expanded form. I'm going to make this long. I have 2 B's, so B times B. I have 5 C's, 2, 3, 4, 5. And then I have 1 D. All right, I'm going to circle my pairs. I have a pair of B's, a pair of C's, another pair of C's. Pull out 1 B, because B times B is B squared. Square root of B squared is B. C times C is C squared. The square root of C squared is C. Pull out another C. C times C is C squared. Square root of C is C. Now, what's left underneath the radical sign? A D, C. Just put it in ABC order. So that'd be C, D. And then how can I condense B times C times C? That would be B, C squared. Okay? All right, let's look at another one. What if I had, what if I put, 110, x to the 4th, y, z to the 3rd. Let's do a really long one here. All right, what do you notice it's different between this one and these two? The only thing that's different is now I have a number. So what we're going to do is we're going to combine both things that we just did together. So the first thing I want you to do is I want you to break down 110. So this will be 11 times 10. That's prime. This is 5 times 2. Okay? So I'm going to make my long radical sign. I'm going to put these in order. You can already look at that. See, I'm not going to pull anything out because it's going to, nothing is a perfect square. Then I have 4 x's. 1, 2, 3, 4. I have 1 y and I have 3 z's. Okay, so we've already established I don't have anything to pull out number-wise, but I have 1, 2, and I have a pair of z's. So pull out 1x. Again, each pair you cross out and pull one of them out. Pull out 1x and then pull out a z. Now, what's left underneath, I just multiply together. So 2 times 5 times 11, that goes back to 110. And then I have a y, and then I have a z. So that's left underneath it. And then outside, just condense it using exponents. X times x is going to be x squared z. So that's my answer to that one. Okay. All right, let's look at a couple more. All right. What about this one? What do you notice about 225? It's perfect. But I'm going to go ahead and bring it down anyway. So 225, 4 x's, and 1 y. So square root of 225 is 25. There's an x, there's an x. Each pair you pull 1 x out. So I'm going to end up with 25x squared on the outside, and what's left underneath? My lonesome y. Okay, now